All right, Haley, I'm going to try to walk you through some of this package. My video times out after 15 minutes, so I'll go through as much as I can in 15 minutes, hopefully clear up some of the things you might be having trouble with here. So, page one, creating and graphing from a table of values. So, you're given an equation, and then you're given a table of values with the x values assigned, and you have to figure out the y values. So, this equation doesn't make it super easy to do the math in your head. So, you probably want a calculator to do it, which is probably it takes a while, especially if you're using the calculator on an iPhone. If you don't have like a nice calculator, I feel for you that this is a bit frustrating. You can maybe use a spreadsheet to do this if you're familiar with how to use those. But if not, I will show you how I would type this into a calculator. So we've got this part in brackets first. Our first x value is -1. So I'm going to put that in 1, make it negative, and then -3. Okay, so I'm kind of following BEDMAS here, doing what's in brackets first. And then everything inside those brackets is squared. So I'm going to square that. And then I'm going to multiply it by 0.5. And then I'm going to subtract 9. Okay, so then my first y value there would be -1. Okay, and then you have to, and then you start to, and then you're going to put in 0, do the same thing, put in 1, do the same thing, etc. Okay, so it does this part, typing your numbers in to get the table of values done, is probably the part that will take the longest. Okay. I do encourage you to do that anyways, though, just because at least a couple times when you're doing this math, you should practice just straight up using an equation and putting in x values and calculating what y should be. Okay, but if you want to check your work, I've got kind of a helpful tool, I think, for you. Desmos you've probably seen this before, maybe looked up at it in class one day. It is a graphing calculator that I think is really powerful. It does a really good job. So you can type in this whole equation that was, sorry, I got interrupted there because the pause button on the recording is right on the button I need to click here. Okay, show keypad. There we go, -9. Okay, so this is that same equation that you can see right here. I've just typed it in. And if you want to check your math, you can actually go in and find the values. So for example, we calculated that when x was -1, y should also be -1. And we can see that that point is on the graph, -1, -1. And when you put 0 in, the result you should get is -4.5. So hopefully that worked out for you. Okay, so I do encourage you to type the values into the calculator, but you can graph your function to check your work, to make sure that the values you put in your table of values are right. So like when x is 2, y should be -8.5. And then when x is 3, y should be -9, etc. Okay, so you can kind of figure those out. You'll notice for this one, I couldn't get the exact value. I was like it's like 1.97 and -8.47. So I can kind of assume that that's close, really close to 2 and -8.5. Okay, so I can kind of round those numbers off a little bit. Okay. Okay, so then let's look at the other information you're asked for. So the coordinates of the vertex. So when you look at a graph, the vertex is either the lowest or highest point. Okay, so parabolas have this like kind of U shape, and it's like the top or the bottom of the U, depending on which direction it opens. So coordinates of the vertex, you can give that point, and you should write it the same way that Desmos does, x coordinate first, and then the y coordinate, and put brackets around it. Direction of opening, so this is just like, do the arms of the parabola reach up, meaning that it opens up, or if it looked like this instead, I just flipped it over by putting a negative out front, so that's a parabola that opens down. Okay? Just so you can see what the difference is. So direction of opening, that's how, so this one, particular one opens up. And then the step pattern, this is an interesting thing. I'm glad that Miss McCourt is emphasizing this for you guys. So the step pattern is what changes happen as you change your X coordinates, I guess, as you go to the right. So I changed the zoom here a little bit so that each grid square represents one. Just makes it a little bit easier to think about the step pattern here. So I start from my vertex and I go over one X value. So I'm starting from 3, I'm going over to 4, and then I figure out how much am I changing in the Y. So when I go over 1, I have to go up 0.5 to get to the next point. Okay? There we go. I found the point exactly. Okay, so then my first step is 0.5. If I go over 1 again and then up until I reach the graph, I get to 5, -7. So I went up, so from -8.5 up to 7, I went up 1.5. So my next step is 1.5. And then my last step here, I'm going over 1 and up 2.5. Okay, from -7 to -4.5. Can I get it exact? There we go. Okay, so I went over 1 and up 2.5. So then my next step is 2.5. So when you're filling in your step pattern here, we went up 0.5, and then we went up 1.5, and then we went up 2.5. Okay, and those are all things that you should be able to read from the graph if you've graphed the points here. I do think that checking your graph in Desmos is totally a reasonable thing to do. However, if your teacher is asking you to take pictures of your work and send it in, you probably also need to write it out on the page. Okay? And you can use Desmos. Another thing that's helpful about it is it can kind of show you what scale you might want to use on your axes. So you could use the scale that's displaying right here, or you could use the scale that I had originally where every 2 grid squares is worth 1 unit, okay? Or you could use the slightly zoomed out one where each grid square is worth 1 unit. That's this version right here. Okay, and so those are the scales you might want to put on your axes here. Make sure that you're labeling your scales before you start graphing points. All right, next thing, building quadratic relations. You are given 12 meters of 1 meter long fence sections, and you need to build a rectangular enclosure which surrounds as much area as possible. Needs to use a river as one of the enclosures, and you can't cut the fence sections. So you want to know the area and the perimeter. So you're making a rectangular enclosure. You only have to build 3 sides of the enclosure. The remaining side is just against a river. Okay, so that would look like this. The perimeter is going to be the length plus 2 widths. Okay, and because you only have 12 meters of fencing, the perimeter always equals 12. Okay, and then your area is going to be length times width. Okay, because it's just the area of a rectangle. So when you're going to fill in these values, you have the lengths assigned, and you just have to figure out how much is left over to make up the width. Okay, so if we think, I'll go back here. So if we think, okay, in the first row of the table, my length is 1. That's assigned. Okay, so if I put 1 in for length, then I only have one thing left in my equation, and I can rearrange and figure out what W has to be. So the first thing I would do is bring the 1 over to the other side. 12 minus 1. I don't know why I wrote it as 1.0, just write 1, equals 2W, and then, so that's 11 equals 2W, divide both sides by 2, and I end up with 5.5 equals W, which means that I have to cut some pieces of fence in half. Should be okay. There's nothing in the rules that says I can't do that. Okay, so then when I'm filling in my table, I go back to my table, I put 5.5 here, and then I can use my area formula to calculate my area. This one's pretty easy. 1 times 5.5 would give me an area of 5.5. Okay, I'll show you one more row there. So let's say I needed to, let's go back here. So area, I'll just show that calculation. Area equals length times width equals 1 times 5.5 equals 5.5. Okay, so those are the two values you would put in your table. Okay, so this is row 1 of the table. Let's do row 2 where length was 2. So 12 equals, I'm just putting in that length of 2 in the table or in the equation, and then plus 2w. I subtract the 2 from the other side. So I end up with 10 equals 2w, and then I'm going to divide both sides by 2, so I end up with 5 equals w. Okay, so that's one value I would put in my table, and then my other value is the area. Area equals length times width, so my length was 2, and my width is 5, so I end up with a length of 10. Okay, so then going back to my table, I would put 5 in, that's the width I found, and then 10 in for my area. And so you just continue to repeat that pattern until you have both parts of the table filled in. You're using the same strategy, sub in the length each time. And what you will likely find is that as the length goes up, the width goes down. Okay, that makes sense because the more fence we use to build the length, the less we have available to build the width. And then you'll see a different thing happen with the area. You'll probably see the area go up and up and up, and then you'll reach a point where you've got the maximum area, and then it'll start to go down. Oh, I lied about the rules here. There is a rule that says you can't have 0.5 measurements. So any rows of the table where you ended up with measurements of 0.5, you can put a line through those, okay? So that would include the first row that I showed you how to calculate there because the width we got was 5.5. So put a line through that one. You can't use that one. And then when you graph your points, you only need to graph the points where there's no half, there's no 0.5s. Okay, that looks like that's the end of that question. Did it ask you? Okay, so once, I don't know how clear it is about this, but once you have finished filling in the table and then plotting the points, you should be able to use that to answer the question here, which dimensions give the maximum area. Okay, and when you plot this, you'll end up with a parabola that makes that opens down, okay? And if you have area here and you have length here, then your parabola will open down and you'll have some vertex that's a maximum, and that gives you the answer to the question, which length results in the biggest area. Okay. I'm going to pause it here, and this will be video 1, and maybe I'll go on and make a part 2 starting from this page you're seeing right here. Okay?